It's completely unpredictable. It's going to explode. No, giving me is not going to provide a valuable chance to go for that. The thing is, it might be tomorrow. It very well might be during this transmission, and it would shimmer like a subsequent sun above us. The James Webb Telescope has, as of late, identified an unforeseen 250% development in the brightness of Betelgeuse, the red star arranged at the shoulder of the Orion constellation. This whimsical behavior has ignited excitement for an intriguing event. Some propose that the abrupt expansion in brightness could indicate Betelgeuse is preparing to go supernova. Yet, the exact timing remains uncertain. Experts conjecture it could happen soon. Join us as we explore the depths of space and unravel the mysteries surrounding this divine giant. Betelgeuse has the potential to reshape how we understand the universe. Despite its name not being commonly known, you've likely appreciated its brightness. A brilliant reddish glow shining at the shoulder of Orion, a prominent star grouping. Betelgeuse's enormity is staggering. If placed at the core of our solar system, its outer surface would extend beyond Jupiter's orbit. This massive star, easily observable, continues to captivate us. Unlike most stars, Betelgeuse's brightness changes over time due to its proximity to our solar system. Classified as a semi-regular variable star, its brightness fluctuates consistently, inching toward a possible catastrophic collapse in a supernova explosion. Recently, Betelgeuse has become even more fascinating due to astonishing fluctuations in brightness. These changes included a significant surge on May 20th, 2023, when scientists observed a staggering 142% increase in brightness, followed by a later update showing a 150% increment. Andrea Dupree, an astrophysicist from the Harvard-Smithsonian Center for Astrophysics, noted that Betelgeuse currently ranks as the seventh brightest star in the night sky, climbing 3 spots from its usual 10th position. From the southern hemisphere, Betelgeuse shines brilliantly in the evening sky, easily visible at the shoulder of the Orion constellation. Dr. Sarah Webb, an astrophysicist from Swinburne University of Technology in Australia, highlights Betelgeuse's importance. It offers a rare opportunity to study the final stages of a massive star's life, providing significant insights into red giants' behavior before they explode as supernovae. When Betelgeuse eventually explodes, it could become incredibly bright for about a week, perhaps casting shadows at night. This prospect has both amateur stargazers and professional astronomers eagerly anticipating the event. Heidi Morris, a researcher at Los Alamos National Laboratory and president of the Padaro Astronomers and Cosmology Club, noted the enduring fascination with Betelgeuse's brightness fluctuations, a phenomenon observed for centuries by various cultures. Currently, Betelgeuse's brightness cycle lasts around 130 days, significantly shorter than its usual 400-day cycle. These rapid changes provide astronomers with a unique opportunity to study this celestial phenomenon in detail, shedding light on the final phases of a star's life. The astonishing behavior of Betelgeuse began in 2019 when it violently ejected part of its outer atmosphere. These fluctuations in brightness are unusual for Betelgeuse, raising questions about whether it will explode into a supernova soon. According to a paper by Dupree and researchers from Harvard and the University of California, Berkeley, it will take another 5 to 10 years before Betelgeuse returns to its normal 400-day brightness cycle. Since the Great Dimming, Betelgeuse has shown consistent changes in light and radial velocity. Despite its erratic behavior, Betelgeuse remains a massive red supergiant star, undergoing the final stages of rapid evolution. As it depletes its fuel, its core will collapse under its immense mass, resulting in a supernova explosion that could outshine entire galaxies. The timing of this event remains uncertain. According to Dr. Worf, a professor of cosmology at the University of Portsmouth, predicting supernova events is challenging due to limited historical data and the complexity of stellar evolution. Betelgeuse is currently undergoing fusion processes, continuously forming elements like helium, carbon, oxygen, silicon, and iron. Eventually, it will fuse heavier elements until it can no longer sustain fusion, leading to gravitational collapse and possibly forming a black hole or neutron star. While some speculate about Betelgeuse's imminent explosion, historical records show it has been reddening over the last few centuries, suggesting it could take significant time before it goes supernova. NASA estimates suggest that Betelgeuse is not expected to explode for another 100,000 years, providing reassurance that its explosion is unlikely to occur within our lifetimes. Despite the uncertainty, Betelgeuse's behavior continues to fascinate researchers and inspire advancements in our understanding of stellar evolution. Dr. Sarah Webb reminds us to remain open to possibilities, even as we acknowledge the unlikely prospect of witnessing Betelgeuse's explosion in our lifetimes. Staying mindful of its changes might lead to further scientific breakthroughs, reminding us to keep hope alive for new discoveries in the universe. It's crucial to understand that our observations of Betelgeuse are essentially glimpses into the past. The light we see from the star is over 600 years old. Hypothetically, Betelgeuse may have already exploded, and we wouldn't yet know about it. While this possibility exists, it is far from certain. History has shown us that our assumptions in astronomy can be challenged. Before 1987, astronomers believed only red supergiants could undergo supernovae. However, that year a massive blue star in another galaxy exploded, surprising experts. This event in 1987, known as supernova 1987A, revolutionized our understanding of stellar evolution. It taught astronomers that stars can behave in unexpected ways and that our models of star life cycles are far from complete. The lessons from that supernova have since encouraged scientists to remain vigilant and open-minded about anomalies like Betelgeuse's fluctuations. Betelgeuse has been an object of fascination not just in modern astronomy, but across history and cultures. Ancient civilizations often interpreted the reddish glow of this star as an omen or a divine sign. Its prominence in the Orion constellation made it a focal point in myths, navigation, and early sky mapping. Today, it serves as a laboratory for understanding the life and death of massive stars. What makes Betelgeuse particularly captivating is its proximity to Earth. At approximately 642 light-years away, it is one of the closest red supergiants to us, allowing for unprecedented observation. If and when it explodes, the event will offer scientists a real-time case study of a supernova, providing data that could take decades to analyze fully. The eventual explosion of Betelgeuse will also have a dramatic impact on our night skies. During its supernova phase, Betelgeuse could become so bright that it will outshine the full moon, casting shadows on Earth and remaining visible during daylight hours. Its explosion will produce a brilliant burst of gamma rays, neutrinos, and other cosmic radiation, though experts assure us that Earth will remain safe from these effects due to the star's distance. As we continue to study Betelgeuse, we are reminded of the vastness of the universe and our relatively small role within it. This red supergiant is not only a subject of scientific inquiry, but also a symbol of the dynamic and ever-changing cosmos. Its fate underscores the life cycle of stars and the processes that shape galaxies, including our own Milky Way. In the end, Betelgeuse's story is not just about a star nearing the end of its life. It's a reminder of how much there is yet to learn about the universe and how interconnected we are with the cosmos. Whether it explodes tomorrow or in 100,000 years, Betelgeuse will continue to inspire wonder and curiosity, driving humanity to look up at the stars and ask the questions that lead to discovery. In the local area, there is still a lot to learn. Also, amazements might lie ahead. Noticing Betelgeuse and other monstrous stars permits us to grow our understanding of divine peculiarities. No matter the shortfall of an impending blast, Betelgeuse's current behavior is spellbinding. Its variance between dimming and erupting reveals interesting physics. The fact that stars throb on human timescales is noteworthy. While Betelgeuse is currently much brighter than anticipated based on its usual multi-day cycle, there's hope it will eventually return to this cycle. However, it is attempting to do so. Later observations have suggested that Betelgeuse might be in a late stage or moving toward the end of the core carbon-burning cycle. This stage involves the transformation of carbon into heavier elements like oxygen and magnesium. If this is indeed the case, researchers foresee a core collapse leading to a supernova blast that could occur within a few years. However, the exact period of Betelgeuse's evolution remains challenging to determine, and uncertainty persists. The possibility of seeing Betelgeuse's blast remains unclear, as the carbon-burning stage can last up to 1,000 years. Studies proposing an imminent blast have not yet been accepted for publication. Nonetheless, considering the potential for Betelgeuse to become a supernova is exciting. It would be an exceptional event, visible even during the day for several days. When the event arrives, the initial signs of the supernova's appearance will be subtle but unmistakable, with neutrinos sweeping across Earth as high-energy photons escape from the expanding cloud of cosmic debris. Betelgeuse will gradually grow brighter in the night sky, possibly reaching peak brightness 10,000 to 100,000 times its usual brilliance within just a few weeks. This scene will amaze anyone fortunate enough to witness it, marking a significant moment in cosmic history. The remnants of Betelgeuse's blast could be as bright as a quarter or half of a full moon, concentrated into a single point of light. This brilliance would be visible during daylight, casting dramatic shadows at night. Predictions suggest it could be 15 to 20 times brighter than Venus, the second brightest object in the night sky. The display of Betelgeuse's blast would linger in our view for about 100 days, captivating space enthusiasts and offering a rare opportunity to observe the aftermath up close. Fortunately, Betelgeuse's supernova would pose no danger to humanity, as it is still significantly far away. Optics and telescopes would allow us to study the event for an extended period without harm. However, such a dramatic event would not go unnoticed. Supernovae were often interpreted as ominous signs, and Betelgeuse's end could inspire fascinating reactions worldwide. Astronomers believe it could even reignite widespread interest in stargazing, awakening people's curiosity on a global scale. Betelgeuse isn't the only red supergiant in our universe. Others could explode before it does. In reality, our Milky Way should observe a supernova approximately every 50 years, yet we haven't seen one in the last 400 years. However, we've observed the remnants of past blasts, suggesting we are overdue for a spectacular cosmic event. It's only a matter of time before the next star puts on its magnificent show for the universe to witness. Betelgeuse's history is rich with significant events, including its dramatic dimming in the fall of 2019. This sudden reduction in brightness perplexed astronomers and sparked speculation about its potential explosion. Although Betelgeuse's brightness returned to normal by April 2020, the reason for its dimming remained a mystery until further observations shed light on the phenomenon. Skywatchers can easily spot Betelgeuse from their backyards, providing valuable observations for scientists to gain a deeper understanding of the star and its dramatic changes. Researchers rely on observatories like the Hubble Space Telescope to monitor Betelgeuse's behavior. The fascination with Betelgeuse isn't just about its potential to explode, but also about the incredible opportunity it presents for scientists to study the final stages of a massive star's life. This giant star, nearing the end of its existence, provides a unique window into stellar evolution and offers the potential to answer long-standing questions about how stars like Betelgeuse behave before their explosive demise. The excitement surrounding Betelgeuse's behavior highlights the unpredictable nature of space. Even with our advanced technology and understanding, the universe continues to hold secrets, surprising us when we least expect it. The mystery surrounding Betelgeuse's behavior is only heightened by the enigmatic nature of stellar evolution. Despite ongoing observations and predictions, we have a limited understanding of the exact mechanics behind these changes in brightness. Betelgeuse's enormous size and the complexities of its stellar cycles make it both a prime candidate for further study and a mystery. As a red supergiant, Betelgeuse is in the final stages of its life, having depleted much of its hydrogen fuel. Over time, it has been progressively expanding and cooling, which leads to its distinct red color and massive size. However, as it approaches the end of its life cycle, the processes occurring within its core are more chaotic than ever before. which may explain its sudden bursts of brightness and unpredictable fluctuations. The study of Betelgeuse isn't just about answering questions regarding its inevitable fate. It's also a way to gain insight into the broader processes that govern the evolution of massive stars. Understanding the details of how red supergiants like Betelgeuse evolve, age, and eventually explode is crucial to our broader comprehension of stellar life cycles. Betelgeuse's eventual fate holds implications for more than just our understanding of stars. When it does explode, the supernova will enrich the surrounding interstellar medium with heavy elements like iron, calcium, and gold, materials critical to the formation of planets, life, and other celestial structures. This recycling of stellar material is a cornerstone of cosmic evolution, making supernovae essential for the creation of new stars and planetary systems. Astronomers are eager to witness this cosmic event in real time. The data collected from Betelgeuse's supernova could significantly enhance our models of stellar explosions, including the mechanisms behind core collapse and the subsequent dispersal of elements into space. This information might even help refine our understanding of other types of stellar phenomena, like gamma-ray bursts or neutron star mergers. Moreover, Betelgeuse's explosion could inspire a new generation of scientists, sparking widespread interest in astronomy and space exploration. A visible supernova would captivate people around the world, reminding us of the vastness of the cosmos and our place within it. Despite the excitement, astronomers continue to stress patience. The unpredictability of Betelgeuse's behavior is a humbling reminder of the limits of human knowledge. While we may hope to witness this spectacular event in our lifetimes, there's no guarantee. It could happen tomorrow, or it might take hundreds of years. In the meantime, Betelgeuse remains a source of fascination and wonder. Its fluctuating brightness and unusual activity serve as a constant reminder of the dynamic nature of the universe. For now, we watch and wait, knowing that when the time comes, the explosion of Betelgeuse will be one of the most extraordinary astronomical events humanity has ever seen.